All right, our first lesson in geometry. I always start out with the Pythagorean theorem. It's a very important theorem. We use it a lot. So, Pythagorean theorem, if you look here, he gets all the credit. His name was Pythagoras. He was a Greek mathematician and philosopher. Um, and he did not necessarily find the Pythagorean theorem, but he made a lot of proofs that supported its truth. So, what the Pythagorean theorem states, it's all relative to right triangles. So Pythagorean theorem can only be used for right triangles. And if you don't know what a right triangle is, that's just any triangle that contains a right angle or a 90-degree angle. So if you ever see a box in a corner like that, that just means 90 degrees. So these are for right triangles only. And it's a special property dealing with the sides of your right triangle. In right triangles, we have what we call legs. I'll call this one leg A and this one leg B. But legs are basically just the shorter sides of that triangle. The longest side, which is typically a diagonal, that is what we call a hypotenuse. And the letter we use to represent that is usually C. But a hypotenuse is just the longest side of your right triangle. Also take into account it is across that 90-degree angle. So I'm going to highlight the hypotenuse right here actually. So let's make note of that. Your hypotenuse is always the longest side across the 90-degree. And like I said before, the legs are just the two shorter sides. Okay, so now that we've established the different sides of your right triangle, let's get into the theorem. What the Pythagorean theorem says is a squared plus b squared, that will always equal c squared. So if I take leg A, square its value, and then I take leg B, square that value, add them together, it's going to equal the hypotenuse squared. Okay, so let's come up with an example. This is the theorem itself. This is definitely what I would start to memorize. A squared plus b squared equals c squared. If you are to leave my classroom remembering one thing, I want it to be this formula right here. Okay. So let's say I have a right triangle. So an example. Okay. So I've got this right triangle. I've got the legs 3 and 4. And I'm trying to figure out that hypotenuse. I want to know its value. Well, if I've got two sides of my right triangle, I can just plug in my values and solve the equation. Okay? So again, the formula is a squared plus b squared equals c squared. I know leg A, I can say is 3. Leg B, I can say is 4. And that's going to be equal to my hypotenuse squared. And then I just continue to simplify. And so the reason why I'm saying this could be 3, this could be 4, if you notice, we have an addition symbol in the middle. So with addition, order does not necessarily matter. The only thing that matters here, order-wise, with Pythagorean theorem, your C should always, always be your hypotenuse. Okay. So in this case, we just simplify. 3 squared, that's going to be 3 times 3, which is 9. 4 squared is going to be 4 times 4, which is 16. 9 plus 16, that's going to be 25, is equal to c squared. And so now I'm at the point where I've got c squared equals 25, but I want to isolate c. I want to have just plain old c like this all by itself. So in order to undo a square, use square root. And basically all that's asking is, what can I multiply by itself to get me that 25? Well, 5 times 5 is 25. So that means the square root of 25 is going to give me 5. And that is my answer. My hypotenuse is 5. Okay, so on your yellow calculators, if you don't know how to square root something, I'm going to show you right now. So again, let's try to find the square root of 25. If you notice, there's a little square root symbol right there in yellow next to the 4. If you hit Control and then hit that button next to 4, a square root box, I don't know if you guys can see that. Okay, a square root box should pop up. And so if I'm wanting to know the square root of 25, I'm going to punch that in. Yeah, this is not doing very well. Okay, there we go. Press enter, and it's given me my answer. Okay. All right, let's try one more. So let's look at example 1. Okay. Again, we have a right triangle, so Pythagorean theorem is an option that we can use to solve for a missing side. All right. If you need to, label your sides as well. Okay. I know this side is my hypotenuse because, again, it's the longer side. It's directly across my 90-degree angle. Okay. And so now I plug in my numbers. I said A was 17. So 17 squared plus 7 squared is going to equal C squared. And then I'm going to figure out those values. So 17 squared is 17 times 7. That's 289. 7 squared is 49. I'm going to add those numbers together to get 338 is equal to C squared. And again, if I want to undo a square, the opposite is a square root. So I'm going to square root both sides. Basically what a square root does here, guys, if I've got a square and a square root with the same variable, it's going to cancel. And so that's why I'm left with C is equal to, well, here, the square root of 338, I'm going to use my calculator to plug that in. So again, you guys can't really see that. Okay. That's what you would plug in. And it's going to give me a decimal. So 18 point, let's round to the nearest tenth. So we'll say 18.4. And that is your hypotenuse. All right, when we flip the page, we're now looking at example 2. This one's a bit different, okay? Before we were looking for the hypotenuse, but in this question, the hypotenuse is this line here, okay? Again, my longest side across from the 90, but they've already given me a number. So I don't have to find the hypotenuse. Instead, I have to find a leg. But I'm still going to use the same formula, okay? So a squared plus b squared equals c squared. I know I can use it because I have that 90 degree. And let's just go ahead and plug in what we know. I'm sorry here, it's kind of getting out of focus. Let's fix that, maybe. Okay, there we go. So 14 we can say is A. B, we don't necessarily know. They've given us that variable x, so we can plug that in for B. And then C, we actually have a value for, that's 50. And don't forget your squares. It should be 14 squared plus x squared equals 50 squared. And let's simplify the numbers that we have. So we're going to take our calculator, 14 squared, that is 196. And then 50 squared is going to be 2,500. Okay, and so now you might get to this point, you may not know what to do, but remember, any goal in an equation is to get x all by itself. We're going to be practicing that all semester. We want x all by itself, and we want nothing attached to it. So order of operations, okay, if you think back to algebra, that's PEMDAS, right? So I don't see any parentheses. I see an exponent, but there's nothing with that variable to work with that exponent, so I can't do anything there. No multiplication, no division. Okay, I'm going to find some addition and subtraction I can work with. So let's look here. If I'm wanting to get rid of a positive 196, think to yourself, what is the opposite operation? If I've got a positive or addition, the opposite is going to be subtraction. So here I'm going to take away 196, but you have to make sure you do it to both sides. Okay, if you do something to one side of the equation, you have to do it to the other to make sure it's balanced. So here that's going to cancel. You're going to be left with x squared is equal to, let's figure out what 2,500 minus 196 is. That's going to be 2,304. Okay, so we're one step closer. X is getting a little bit more isolated, but now we have an exponent to work with. So again, how do we undo a square? We square root. So that's going to be x is equal to the square root of 2,304. And when you plug that in, that is going to be 48. So again, working with opposite operations, that's really crucial when we're solving for variables. So if you need a refresher, make a little note here. Opposite operations. So if I have addition, if I want to change that or move things over, I'm going to do the opposite operation, which is subtraction, and vice versa. If I've got a negative value, the opposite operation is going to be a positive value. If I've got division, the opposite operation of division is multiplication. And then same thing, the opposite of multiplication is division. Okay, so keep those in mind as we're solving. Okay, let's look at example 3. Example 3 is a very good problem because it is a word problem on EOC. They are probably not going to give you a simple triangle like this. They want you to know how to do this by looking at a word problem. Okay, so go ahead if you need to pause the video, read that problem really quickly. But I'll go ahead and get started. So key information, we have a zip line to start at a platform 450 meters above the ground, and it's going to end 775 meters away from the base. How long must the zip line be to meet the designer's specifications? First of all, I'm going to draw a picture. Anytime in my classroom y'all have a word problem, you need to go ahead and figure out a picture that represents that problem. So obviously, if we're using Pythagorean theorem, I need a right triangle somehow. It says the last zip line is to start at a platform 450 meters above. That's the key word there, okay? If something is above, that's going to be like vertical distance. So 450 is going to go here. And it's going to end 775 meters away from the base. So away is kind of indicating horizontal distance. So 775 is going to go there. And it's asking how long must the zip line be? And so, if you think about a zip line, if you've ever rode one before, it is kind of a diagonal line. So really what we're looking for here is the hypotenuse. So again, if I get my formula ready, a squared plus b squared equals c squared, plug in what I know, and then continue to solve. Okay, so this one was a pretty simple one. You just plugged in your numbers, and I went ahead and done the math for you guys. But when you square 450, you get this big number. Same thing here. When you combine those numbers, you get 803,125. Now that's equal to the hypotenuse squared. So if I just want the hypotenuse, you have to make sure to square root that to get your final answer. And so when you take the square root of that number, you get 896 point, we'll round to the nearest hundredth, so I'll say 0.17. And so in this context, it's talking about meters, and I'll also include that unit. Now, a question I really like here to the side, it says, think about it. Is your answer reasonable? Use estimation to justify your reasoning. So think to yourself, is it reasonable for the hypotenuse to equal 896? Well, if we go back to our original notes, right? The hypotenuse, by definition, is the longest side across from the 90-degree angle. So if we go back here, using our measurements that we have found, okay, 896 must be the larger number if that actually is the hypotenuse. And in this case, that is true. 450 and 775 are less than 896. So that's a good way to double check yourself. If you get a number for the hypotenuse that is smaller than these legs, something's went wrong. So be mindful of that. All right, last thing that we're going to look at, if you turn to page 515, we're looking at the converse of the Pythagorean theorem. Converse just means the opposite. So before we learned what the Pythagorean theorem was, and we said, okay, if it's a right triangle, then a squared plus b squared equals c squared will work. And the converse just means the opposite. So if a squared plus a squared plus b squared equals c squared, if that actually works out for us, then we know for sure it is a right triangle. That's what the converse means. So let's look at an example. Let's say that I'm given the following measurements. I have a triangle, and it has the sides square root of 5, square root of 12, and square root of 13. And you're asked, does this form a right triangle? Well, we're going to plug in these values, and we're going to see if Pythagorean theorem works. If it does, then yes, it is a right triangle. So what I would first do is pinpoint, okay, which one's going to be the largest number? With square roots, same rule follows as regular numbers. The largest is going to be the largest number. So that is my C. So let's plug stuff in and see if it works out. The square root of 5 squared plus the square root of 12 squared, is that equal to the square root of 13 squared? Okay. So again, let's use our calculators. Well, I say use our calculators, but I'm actually going to backtrack. Let's look at what we have here. So we have a square root and a square. So those will actually just cancel. So if you square the square root of 5, you're just left with the number 5. Same thing here. If you square the square root of 12, you're left with 12. Okay. And then let's add these together. So 5 and 12, that's going to be 17. So is 17 equal to 13? Well, no, obviously. Okay, those are not the exact same number. So because this did not work out, no, those particular sides do not form a right triangle. They may form a different triangle, and we're going to get into that like way later, but specifically a right triangle, no, that's not going to work out for us. Okay. Let's think of another one. Let's say we have the sides, we'll do 6, 8, 10. Okay. So again, identify your hypotenuse. Obviously, 10 is the biggest number, so that's going to be our C. And let's plug it in. Does 6 squared plus 8 squared equal 10 squared? 6 squared is going to be 36. 8 squared is going to be 64. 10 squared is going to be 100. When I add these together, do I get 100? The answer is yes. So 100 equals 100. That is a true statement. Okay. So in this case, yes, these sides do form a right triangle. Okay. And so that's all we're going to look at for now. You have a back sheet that talks about coordinates. We're not going to get into that just yet. So thank you guys for following along and taking your notes. And please reach out to me if you have any questions.